Welcome back. Today we're going to look at topic 1.2, perfect squares, cubes, and their roots. So let's get started by looking at our learning targets. By the end of this lesson, you should be able to determine if a number is a perfect square, perfect cube, or neither. You should be able to determine the square root of a whole number, the cube root of a whole number, and then solve problems that involve factors or perfect squares and perfect cubes. All right, so let's take a look at the lesson. We're actually going to start at the end of the lesson and then go back to the beginning. So we have two examples here. Example number 5 says a floor mat for gymnastics is a square with an area of 196 meters squared. What is its side length? So we're going to sketch our square, which means all of our sides are equal, and we've got 196 meters squared. Our challenge is to figure out what the lengths of those sides are going to be. Because this is a square, my sides are the same, so I'm trying to find two identical numbers that multiply to be 196. One way to do that might be to list all of my factor pairs. Well, looking at our factor pairs, we can see that 14 and 14 would be my side lengths. So 14 meters by 14 meters. Another way might be to do birthday cake. So we're going to take 196, and if we divide by 2, 196 divided by 2 is 98, divided by 2 is 49, divided by 7 is 7. So writing that out as prime factorization, we have that 196 is 2 times 7 times 2 times 7. And if we group those, we can see that 2 times 7 is 14 and 2 times 7 is 14. So 196 is 14 by 14. So that's going to be my side length. A third way to do this is to take the square root. If I take the square root of 196 meters squared, I'm going to get 14. So the square root of 196 is 14 because 14 is one of the identical factors that multiplies to be 196. Now, if I think about the units, I've got 196 meters squared. Just like I can square root the 196 and get 14, the square root of meters squared is meters. So my side length is 14 meters. So let's take this information and connect it to the start of our lesson. So today we're talking about perfect squares, cubes, and their roots. So a perfect square is the product of two identical factors. So 49 is 7 times 7. 64 would be 8 times 8. Another perfect square might be 81. It's 9 times 9. So a perfect square has two identical factors. The flip side of that is a square root. A square root is just one of the factors of a perfect square. So I said before that 81 is a perfect square. If I take the square root of 81, I'm going to get 9. Now let's talk about what our perfect squares are. These are some numbers that you're going to want to memorize. We're going to be looking at breaking down entire radicals later on in this unit. And the better you know your perfect squares, the quicker you're going to be able to do that. So 1 squared is 1. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, we've got 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. And so I would recommend that you memorize up to 15 squared. Absolutely, we have access to our calculator and we can definitely use that to check. Honestly, I mix up 14 squared quite a bit. It's the one that I typically forget, but it's really helpful if you can memorize up to 15 squared. Now, when we're talking about perfect squares or square roots, we're dealing with area. So if my area is 49, that means my side lengths are 7 by 7. When we're talking about perfect cubes or cube roots, we're relating to volume. So we're dealing with 3 dimensions. So if the cube root of 27 is 3, that means if my volume is 27, my side lengths are 3 by 3 by 3 because volume is length times width times height. So a perfect cube is the product of 3 identical factors. 27 is 3 times 3 times 3, or 27 is 3 cubed. Just like earlier, we had 49 was 7 times 7, so 49 was equal to 7 squared. When we think about the reverse again, a cube root, the cube root is one of those factors or one of those side lengths. On your calculator, what you can do to find cube root is to push the math button, and then we choose number 4. So you can arrow down to 4 or just type 4, and then 27. So we want the cube root of 27 is 3. That means that 3 cubed is 27. So just like we were listing our perfect squares, we also want to list our perfect cubes. So 1 cubed is 1, 2 cubed is 8. Remember that means 2 times 2 times 2, not 2 times 3. 3 cubed is 27, 4 cubed is 64, 125, 216, 343, and then moving down here, we've got 512, 729, and 1000. So for the perfect squares, I'm recommending that you memorize up to 15 squared. For the perfect cubes, I'd recommend memorizing up to 10 cubed. Honestly, I get stuck after about the 6 cubed sometimes. If you had to check these on your calculator, the squared button is on your calculator here. So if I wanted to go 7 squared, I just push the button there. For cubed, the easiest thing to do if I want to do 6 cubed is do 6, the little hat, and then cubed. If you have a TI-84 plus, you'll see that it puts it right into exponent land for you. But we can just do 6 cubed. There is another way you can do 6 and then math and then choose number 3, but that's a lot more button pushing than we need. So I would just go 6, little caret, and then 3. So let's take a look at estimating roots. Not everything is always going to be a perfect square. I mean, when we think about construction, it's very rarely that I have a square or an area of a floor that's exactly 196 meters squared. There's usually some decimals involved and whatnot. So not everything's going to be a perfect square. If I want to estimate what the square root of 200 is, I can use perfect squares to do that. So let's think about our perfect squares. We're going to go back to our list above, and we want to find numbers that are close to 200. And so we can see from here that 14 squared is just below 200 and 15 squared is just above 200. So I'm going to draw a number line here, and I know that the square root of 196 is 14. And I know that the square root of 225 is 15. So I need to figure out, where does 200 fall? Well, 200 is definitely going to be a little closer to 196, so I might write root 200 about here. And then looking at my scale, I might estimate that root 200 is about 14.1, maybe 14.2. I can check that with my calculator. On my calculator, I can do second function square root, type in 200, and it tells me that the square root is 14.14. So 14.1 is a pretty good estimate. I would think that if you had 14.2, that would still be very realistic. It's important that you're able to estimate without just plugging it into your calculator, because we do make mistakes when we type things into our calculator. And if we don't have the ability to estimate, we don't always have that radar that says, maybe that doesn't sound quite right. So while absolutely we can just type these into our calculator and see what the answer is, it's important that we also are able to recognize whether this is a realistic answer or not. So let's take a look at a cube root. So we're looking for the cube root of 75. So we're going to go back to our cube roots list here, and we're going to see that 75 is between 4 cubed and 5 cubed. So making our number line, we're going to do the cube root of 64. Notice there's that little 3 in there, that's called our index. So we've got the cube root of 64, and then we have the cube root of 125. Well, the cube root of 64 is 4, the cube root of 125 is 5, and so we have to figure out, where does 75 fall? 75 is a little bit closer to 64 than it is to 125, so I'm going to put it maybe about here. And so maybe estimating about 4.2, 4.3, I'm going to estimate 4.3, and that would be close. Now, if I go and check on my calculator and I want to do cube root, I can type math and then 4 for cube root, type in 75, and it says 4.217. So 4.3 would be a realistic estimate. Now again, we've already talked about determining square roots. These are just some extra terms that you might see. If you're asked to determine the square root of 256 using a diagram, then we're just talking about area. So you would draw your square. We know that the area is 256, and we're just finding two numbers that multiply to be 256. In this case, that would be 16. On my calculator, I would be typing in the square root, so second function square root, 256, and that's 16. So 256, the square root of 256 is 16. Prime factorization we've talked about as well. So if I have 256, I'm going to break that down using birthday cake. Because we're looking for a square root, we're looking for pairs or two identical sides. So I'm going to break these into pairs. There's 2, 2, 2, and 2. And notice there's no leftovers because if this is a perfect square, there should be no leftovers. So my square root of 256 would be 2 times 2 times 2 times 2. Remember, each circle we pull out the number one time. So this would be the same as 2 to the fourth. The square root of 256 would be 16. Now taking a look at cube roots, the process is exactly the same. When we're dealing with a cube root, we're talking about volume. So that means we're going to be drawing a three-dimensional object. And we need to figure out what three identical numbers multiply to be 3375. So we're going to go to the calculator step here first. We've got the cube root of 3375. And if I put that into my calculator, I would go math 4, 3375, and that gives me 15. So representing that with a diagram, I would have my 3375 as my volume, and my side lengths would be 15 by 15 by 15. Now with prime factorization, again, we start by doing birthday cake. All right, once we have our birthday cake done, we're looking for triples because we're dealing with cube root. That means we're looking for three identical numbers. So we're going to put these in groups of 3. There's a group of 3 and there's a group of 3. So the cube root of 3375 will be 5 times 3, which is 15. Now, moving on to example 4, it asks us to use prime factorization to determine if 729 is a perfect cube, a perfect square, both, or neither. So again, we're going to start off with our birthday cake. Now, I've written these out 2 times because we're checking to see if it's a perfect cube, a perfect square, both, or neither. Now, if it's a perfect cube, that means I can break my prime factors into groups of 3 and have no leftovers. So if we take a look at the first one here, I've got a group of 3 3s, another group of 3 3s, and so this is a perfect cube. If I were to write down or represent what that is, I would have the cube root of 729 is 3 times 3, which is 9. And again, if I wanted to check that on my calculator, the cube root of 729 is 9. Now to check to see if this is a perfect square, I need to be able to break my prime factors into pairs and have no leftovers. So taking a look here, I have a group of 3s, another pair of 3s, another pair of 3s, and I have no leftovers. So this is a perfect square. That means that the square root of 729 is 3 times 3 times 3, which is 27. Again, checking this with my calculator, the square root of 729 is 27. So in this case, 729 is both a perfect square and a perfect cube. Let's take a look at our final example. It says that the volume of a cubic box is 150 meters cubed. Determine the dimensions of the box. Now this is one example where there isn't a whole number that's going to multiply to be 150 meters cubed. This is one that I would have to do with my calculator. So again, if I'm talking about volume, I'm looking at a cube. My side lengths are identical. So I've got V equals 150, 150 meters cubed. And in order to find the side length, I would have to take the cube root. So if I have the volume of a cube, I'm taking the cube root to find the side length. If I have the area of a square, I'm taking the square root to find the side length. So on my calculator, I can find the cube root of 150, which is 5.3. And again, if I'm cube rooting meters cubed, that's going to leave me with meters. So the cube root of 150 is 5.3. So the dimensions of the box are 5.3 by 5.3 by 5.3 meters. That's everything for today, guys. Hopefully you have a good understanding of perfect square, perfect cubes. Definitely take some time to memorize your perfect squares up to 15 squared and your perfect cubes up to 10 cubed. It will definitely come in handy later on in this unit. Thanks a lot, guys. Have a great day. See you next time.